Hi, this is Dr. Shoba, Professor, Computer Science and Engineering Department, RV College of Engineering, Bangalore. Okay, just to introduce about the college, this is a private autonomous college affiliated to Vishwesvaraya Technological University. So it is a topmost college in Karnataka, and I belonging to Computer Science and Engineering Department. We have cream students, and all the faculty in our department are involved in research activities. We have collaboration with n number of industries. To name few, we have Citrix, LexisNexis, Cisco, and HPCC, etc. So the purpose of coming here and giving a talk is to have collaborations with the startups and other industries also. Okay, so the session, whatever I'm giving, is a part of the project that is carried out for a Japanese company. To begin with, the agenda goes like this: introduction and motivation, components that is involved in natural language processing, for conversion of natural language to SQL, rule-based architecture for natural language to SQL conversion, and the architecture that is used to enrich natural language for SQL conversion, HPCC systems architecture, and finally the results and conclusions. So what motivated to take up this project? As we know that relational database, okay, the market of the relational database is increasing episodically. So you can see here in 2017, it was $23 million. And now to 2022, it is expected to be $34 billion. So even though the NoSQL part has come into the market, still relational database claim majority of the market. So this is the slide that gives you the picture of worldwide relational database market size, okay, which excludes data warehousing. So the trend for relational database and its storage is a very important concept, okay, that we need to take care of it. Since relational database takes majority of the databases, the access of data from the database, one needs to know SQL. But what are the challenges of SQL? It is critical to access the data and learn the query language. Okay, so learning the query language, understanding the syntax, it takes a huge amount of time. But most of the company uses this as this relational data. So what is the remedy for this? The go-to solution for this is convert a natural language to structured query language. So given a natural language, that particular language can be converted into structured query language to access the data from the storage. So in order to do this, we are making use of natural language processing. So before we go into the algorithm, what are the components that are involved in natural language? Okay, so NLP, as you already know, it is a part of computer science and artificial intelligence, which deals with natural language processing. So what are the components that are involved? The first one is, given a natural language, okay, I have to convert that into token, which is called tokenization. Each word is nothing but a token. Then from the token, the next part of the natural language is stemming. So stemming gives you like the most important word that has to be captured. For example, say jump, jumps, jumped. Okay, so all this will be linked to jump. So instead of storing all the thing jumping, okay, jumped, okay, this will be linked to jump. Then coming to lemmatization. So lemmatization is nothing but it is similar to stemming, but it takes the dictionary word of jump or whatever it is. For example, if I say believes, okay, so believes, what it will do, ES, stemming, it will remove ES and it will give the other part of the characters. But in lemmatization, what the dictionary value of beliefs, that is belief, will be taken into picture. The exact word of the dictionary will be taken into picture. Then next is post tagging. Post tagging is nothing but, okay, you have to tag the tagging of each word, whether it is a noun, verb, or adjective. After this, next comes the named entity recognition. So it is going to recognize the entity, whether it is a person, location, or anything. Then chunking is nothing but grouping the words. For example, if I have a phone number, Okay, so phone number has what? Area code and the access number. So country code, area code, and the access number. So this will be grouped into the particular the access codes. So that is nothing but the chunking. So first thing is already currently the existing is rule-based architecture. Okay, rule-based architecture is already existing for natural language to SQL conversion. Okay, so rule-based, as the name itself denotes that you have some rules, okay, which converts the natural language to SQL. So as you can see from the figure, you have the user, he enters the query, or query in the sense in terms of natural language. Say, retrieve the names of the people, okay, who work for a company. Say, if I take a company database, I want to retrieve the names of the employee who work for a company database. So this will go to the pre-processing. So in the pre-processing, the exact SQL classes, okay, are being filtered. So SQL classes in the sense we all know that distinct, all the distinct operation. You have count, average, min, max, sum, join, where, all these things will be extracted. So given a natural language, the SQL classes will be extracted. Then after that, you have something called entity extraction. So once the intent is recognized, next is entity extraction. The input of this is post tagging and data parsing. So entity can be a date also. Okay, so that date, and also you have post tagging. Post tagging is nothing but you have like retrieve the names of employees. So what are the nouns? Okay, what are the verbs? Okay, all this will be taken care by post tagging. Then finally, after this entity extraction, you have a set of keywords. So in the set of keywords, you may have a date, okay, and other things may be a probable attribute names. Okay, so this probable attributes names will be taken to the classifier. So in the classifier, this is the classifier. The input of this is the attributes, probable attribute names, plus the user-defined schema. So given a database, okay, you have a schema. That schema contains the mapping, like what are the column names, what are the attributes, what are the constraints. All these things are defined in the schema. So those things also will be taken care by the classifier. So this classifier, under this you have direct check. So direct check, where it maps whether it is an attribute name or a constraint, or you are making use of a join, or it is a data type. Okay, that is direct check. Next comes the concatenation. If the attribute is not clear, okay, you combine with one or two words before and after and check whether it is a particular word which we are looking for. Okay, so if this also cannot rectify the problem, then we will go for n-gram check. N-gram check is you have 2-word check, 3-word check, 4-word check, etc. Then the next is hyperlink check. For example, you have red. Okay, I want to know the employees, okay, who are involved, okay, who are involved in some project, say some red denotes some color, isn't it? So red, white, violet, purple, all these are nothing but the color. So it will map to the color. That is nothing but hyperlink check. Then similarly, some of the attributes, while giving a natural language, some synonyms can also be given. Okay, so that also the checking will be done. So here in the classifier, you have the probable attribute relation names plus the other things from the user-defined schema. Other things in the sense, you have table name, whether it is the name of a table, whether it is the name of a column, whether it is a constraint or any redundant words. Okay, all this will be checked. And finally, we get the table names plus the column names and some residue. Residue is nothing but the probable data, right? So next is we will filter out all the anonymous words. And finally, it will be passed to the SQL query. So SQL query constructor has the input from the intent recognition, that is the SQL classes plus the tables, whatever you have got. Okay. Next is the output of this SQL query is nothing but the post processing, okay, which queries the store database and gives you the result. So this is nothing but the rule-based method of generating an SQL query. Okay, so natural language is given and we have rule-based. Based upon the schema, we decide the table mapping, column mapping, join, constraint, all this will be taken into picture. Okay. So this is nothing but the rule-based mapping. So what are the challenges that are faced by rule-based architecture? This will be specific to the schema, and identification of partial or implied data values is not possible. And even the descriptive values will be a challenging job when we make use of rule-based. So the solution is to go for machine learning techniques for natural language to SQL conversion. So what are the technologies that are being used for NLP to SQL? So we have feed-forward neural networks, recurrent neural networks, but both of them have a problem. The problem is it cannot capture long-term dependencies due to vanishing or exploding gradients because of backpropagation. That is, during backpropagation, it is not possible to capture long-term dependencies. For example, if the gradient is less at the starting, then as and when it propagates, okay, the gradient will again decrease. If the gradient is more, okay, as and when it propagates, it explodes. So the solution for this is LSTM, that is long-term memory model, long short-term memory model. So this is a type of recurrent neural network which addresses the problem of vanishing or exploding gradient problem. And this allows learning of long-term dependencies. This particular LSTM, it has prominence with the state-of-the-art performance in speech recognition, language modeling, translation, and image captioning. Okay, as you can see in the figure, you have, say, input gate, output gate, and also the forget gate. Okay, so this gate will not only have an input, it also has the previous output. Okay, it takes the input from the previous output. Okay, so this is the LSTM memory cell. Okay, so it has two functions, that is sigmoidal and tangential. So the input to this is nothing but you have a memory from the previous block, output of the previous block, memory from the current block, output of the current block. So 4 things will be there. So this allows the long-term dependencies. Okay, so this made us to use LSTM model. So this is the architecture of LSTM model based conversion of natural language to SQL. So this method basically enriches the natural language. For example, if you have a relational database, first thing is I have to identify what are all the descriptive search. So this descriptive search will be taken by the other open source, that is by means of Elasticsearch. So once the data set is extracted, that means the relational database is extracted in the form of CSV format. So it will be pre-processed. So the pre-process, as you can see in the other slide, we are making use of a cluster, and the data is sprayed into the cluster, and we are converting the data into the unique values. Okay, wherein we are tokenizing it, and we are encoding with one-hot encoding technique is also used. Okay, basically to get a unique binary value. We make use of random sampling also, so that we get a unique value for each of the attribute values. Then finally, we are taking a proper value. That is, we are padding and truncating so that we get a proper unique integer value. Okay, this is the pre-processing techniques. Once the data set in the CSV format comes to the pre-processing, it will convert that into a unique integer value. Then it is passed to the word embedding. So word embedding, as you can see from the figure, you can see there king, man, okay, boy. So all this is nothing but a male gender. So it will be linked to the male gender. Similarly, you have verb, walking, walked, everything will be linked to the walk. Okay, country capital. So we are embedding it with respect to the context, what the language is using, that what context the particular relation database has been got from the pre-processing. Finally, this word embedding will be an input to the LSTM model. Similarly, this part, when I give a natural language, okay, this will be converted into a list of n-grams. Okay. From there, we are lemmatizing it to know the exact word from the dictionary. Okay. Then we have hyperlimbs. Hyperlimbs, as I told you, that regarding, say, color, red, blue, green means all this matches to a color. So it will be linked to the color. So similarity search. So you may have different words, synonyms you may have. So all this will be taken care in the similarity with the attributes. Okay. Then finally, the output of this will be list of data values or enriching the natural language. Okay. Finally, this particular thing will enrich the natural language, whatever the user has given. Okay. So this is about the architecture. Then for the descriptive values, if I want to search for a descriptive value, then we make use of an elastic search. Again, it is an open source. Okay. So this identifies the descriptive values from the data, from the relational database. So these are the techniques: preprocessing, embedding, and LSTM. So the LSTM input, you have the word embedding and also the n-gram. Then once the model also classifies the implied data values. So what is that classification is? The input natural language query is tokenized and it is split into different sequences. Sequences of one word up to the sequences of n words, where n is nothing but the number of tokens, which is mainly used for prediction. The largest sequence and its classification are considered, and all the subsequences are ignored. Finally, the high confidence classifications are given to the LSTM model. And this can be used in multiple ways, either to enrich the natural language or to store the data values and the attribute values. Okay. So why we are using Elasticsearch is, the reason is to get the description of the words. Okay. If any query is with respect to the description. Okay. Say, for example, in the table, you have a description of the product. Okay. So I want to search for a particular description to which product it belongs to. Okay. The description can be 4 to 5 statements. Then it will be difficult to make use of machine learning. Although we have tried with the machine learning, but it doesn't give that accurate result. Since it is only a part of a relational database, it is not a huge thing. Only hardly I may have one column as a descriptive or two columns. So we made use of Elasticsearch. So the extracted CSV file is used to create index in Elasticsearch. So Elasticsearch bulk API, it provides the necessary function that can create and store large data simultaneously. So what are the components of Elasticsearch? We have two things. The first one is analyzer and the second one is the searching through multiple attributes. So in the analyzer, you have again two types: stop analyzer and English language analyzer. For example, if I say get the doctors with a master's degree, what the stop analyzer will do is it will discard the stop words. It will just get the output as get doctor's master's degree, as you can see here. The English language analyzer, what this will do is it will take the input query to the root word. Now, say for example, the input is show all products which are red bikes. Now, in my database, I don't have products. S is missing. So I have only the name as product. So what this analyzer will do is it will check with the relational database and find out the similarity, okay, which is the similar attribute name, and that will be the output. So the analyzer will give show all product which road bike. So you can see here R and the products is again converted to product. Okay, this is what the analyzer will do. Next is searching through multiple attributes. So Elasticsearch has two things: analyzer and multiple attributes. So this multiple attributes, the query you can see is multi-match and the field. The field contains the list of descriptive columns. So this will be again converted into SQL, where field name 1 is equal to value 1 and field name 2 is equal to value 2 and field name n is equal to value n. So this searching of the attributes will be converted into wait clause in the SQL. So you can see this, you can visualize this. You have database in SQL and that is converted into data in CSV. That means we are taking the descriptive value separately. Then we have to create an index in the Elasticsearch. Okay, when we give an input in the natural language, it will be taken by the stop analyzer, language analyzer, then multi-match search will be used using the index created. From this, the output, whatever we get is the where clause. And this where clause will be appended to SQL. So finally, what we get is the SQL output. So we have used this particular database. We have sprayed it in a HPCC systems cluster, which is an open source lightweight, and it is a powerful big data management platform, which serves as an end-to-end data lake management solution. This big data can be a structured, unstructured also. But here our concentration is with the structured data, that is relational data. Because of the huge amount of relational data, as we saw, okay, iteratively to convert to SQL, it takes lots of time. So instead of this, the data is sprayed into the HPCC. Okay, so this you have a Thor cluster and a Roxy cluster. Finally, the data will be converted, whatever the natural language or the user will be giving will be converted to the SQL. So HPCC cluster is only used for spraying the data. So you have three main parts in this architecture. The Thor, which is a data refinery engine, and provides the user the control over the data transformations, and also facilitates the optimal operational capacity on the mixed schema data. As we have seen the difference between the rule-based and machine learning techniques, rule-based is specific to a schema, but machine learning is not specific. So it is generalized. I can make use of any schema, okay, and any natural language can be converted into the SQL. So that facility is provided by the Thor. And we have a Roxy, with basically a search engine to find out the data wherever it is played in the cluster. Okay. Then the language that is used is ECL, it is Enterprise Data Control Language, which is parallel data processing and which follows data flow architecture, and it is also declarative in nature. So both SQL and ECL, both are declarative in nature. Okay. So since taking the advantages of HPCC systems platform, we developed the synchronous combination of hybrid machine learning model, Elasticsearch, WordNet, and HPCC system platform to convert an natural language to SQL. So these are the results. Suppose if I have a query, say, show all unmarried customers who are men. Okay, this is the natural language. So the machine learning, what it will do is it will enrich the natural language. Okay, so you can see here men, unmarried men it is, isn't it? So it is enriching, the technique is enriching by converting this particular natural language to show all single gender male customers. Okay, this gender is in the database, isn't it? So the gender will be taken care and male also will be in the database. This, by enriching this, we get the correct query. The output of this particular SQL query, as you can see, select star from the name of the table where, okay, lower material status is equal to single and gender equal to male. So the main purpose of machine learning is we are enriching the natural language to a particular language so that you get a proper SQL query. Okay. So you can also see this names of the customer who have graduated and from Germany or France, who have graduated, and they should be from Germany or France. This is the natural language we have given. Now names in the database, there is nothing like name. There is something called full names. So this will be enriched to full names of the customer who have graduated. In the database, whatever we are using, there is no graduated. So it belongs to education. So this machine learning, it will convert that graduated to education and the value will be graduated. So this is the name of the column. So education is the name of the column. In that you have the value graduated. Then Germany or France, this is nothing but a country region. Okay. So this will be again embedded to country region, that is Germany, or country region is equal to France. Now this enrich enriched natural language will be easier to convert that into SQL. So we have all the attributes, whatever is there in the database. So the same attributes will be taken care and converted into the SQL, as you can see here. Okay, you have select T customers. T customer is the name of the table. Okay, then dot full name. Full name is in the database, in the relational database. From T customers, join it with the other tables, whatever is necessary to get the name of the customers. Okay, so like this, the language will be enriched. So these are the few more example. Okay, you have get the price of red or dark helmet. Okay, now red and dark helmet, where which column that we are not aware. So our package, what it will do is red or dark helmet will be is nothing but a color. So this will be enriched to get the price of color red or color black. Next is helmet. Helmet is a product, but it belongs to subcategory. Okay, so if I go for a rule based, then it will be difficult to find out where that particular helmet is belonging to that particular relation database. So this helmet will be converted. Okay, will to product subcategory name. So this is how the enrich of the natural language takes place. And finally, we get the SQL query, as you can see here. Okay, so this we have tried it out for a number of queries. Okay. And finally, the conclusion for this is partial and implied data values in the natural language queries are identified by the trained hybrid machine learning model. Then we have made use of WordNet as a safety net to understand the implied data values where the vocabulary of the input relation database is not expressive. Descriptive values are also identified by means of Elasticsearch. Then we have tested the accuracy of the machine learning techniques, whatever we have developed, by making use of IMDb database. It is an open source database. The accuracy is around 91.7%. Okay, so thank you. So any questions? So I'll be reachable through this mail, shobaji@rvce.edu.in, and the website is here. So if any questions, you can come back to me. Thank you all.